Hey guys, and welcome to the show. We've got a great show for you today. In fact, it's the second part of a show that we did 1 year ago today. And that's when we had Norm Judah, Chief Technical Officer for Microsoft, on. And he and I both made some predictions. We're going to follow up on that a little bit today. But before I invite Norm in, I want you to watch this video about the HoloLens.
Look around. Technology is all around us. We use it in every aspect of our lives. It enables us to do amazing things. But what if we could go further? What if we could go beyond the screen? Where your digital world is blended with your real world. Now we can. This is the world with holograms. What will they enable us to do? New ways to visualize our work.
I have an idea for the fuel tank.
New ways to share ideas with each other.
How are things going your end?
I just put the images in OneDrive.
Perfect.
More immersive ways to play. New ways to teach and learn.
So put the new trap in the place of the old one.
Now what?
And tighten here and here.
New ways to collaborate and explore the places we've never been.
Look at this formation. Let's take a closer look.
And new ways to create the things we imagine. Because when you change the way you see the world, you can change the world you see. This is Microsoft HoloLens.
Hi guys, and welcome to the show. And I am back with Norm Judah. Norm, how you doing?
Great. Great to be back. It's wonderful to sort of look forward and backwards at the same time. So thanks for having me back again.
It is. It's a lot of fun. And I went back and looked at the old show, and we talked about some stuff that a year ago that, you know, I probably thought was 5 or 6 years in the future. But
that was so yesterday. It was so yesterday.
Yeah, exactly. To be honest with you, a lot of that stuff is here now.
Yep, it is.
Right. We talked about instrumented socks. Remember the instrumented sock? Yeah. We talked about 3D printing and being able to order stuff and have it printed locally.
Yep.
And we talked about park benches that would be aware of your location.
Yep.
And so we've almost got that, right? We've got Microsoft has the wearable band.
Yep.
Right?
Lots of those around.
Lots of those around. We've got Cortana, which isn't a park bench, but she knows where you're at, and she can make decisions based on where you're at.
Well, not only where you're at, where you've been and where you want to go to. So both of those.
That's absolutely correct.
Yeah.
Yeah. And I was reading today about a new 3D printer that will print pizza. So
I don't know if I would eat that, though, but it sounds like a great idea.
Yeah, so here's it. The cool thing about it is it was actually in a NASA blog, and one of the things that they're looking at for the trip to Mars is how do we feed these people for 15 years? How do we get, we can't send food with them that will last for 15 years because that's kind of hard to do. And so what they do is they break it down to its core component, and then they can actually print the food. Yeah. They've got proteins, they've got carbs, they've got all of this stuff, and they can print the food. And what they're saying is those individual components have a shelf life of about 30 years. So it solves the problem.
That's not 3D printing, it's 3D cooking.
3D cooking, yeah, exactly correct. Well, actually, I guess you'd go ahead.
Let me come back to that. There's a great example of 3D printing right now about how the market is being disintermediated. If you look at any of the sort of current music people in the industry on stage, they all wear a headset that sort of has a wire that comes out of the top of the ear and comes around the back. You can tell them by that look. It's a company called Incredible Ears. To get that made, you actually go to an audiologist. They take a mold of your ear and they send it to the company and they make this insert that matches your ear perfectly. And the sound is stunning, costs about $1,200. But the sound is amazing and it's custom to you. There's a new company called Normal that's based in New York. They have a store in New York and a store in LA, and they have an app. And what you do is you hold a quarter next to your ear so they've got a reference size, and then you take 3 or 4 selfie pictures of your ear, which sounds a little crazy, taking a selfie of your ear. You send that to them in the app, and then they 3D print the insert into your ear based on that and customize it. You can have it in any color you like. You can have it in any finish that you like. And it's not quite as good as Incredible Ears, but it only costs $200 instead of $1,200. And it's basically printed on site. You can either go into the store and do it, or you can send them your pictures and get it delivered the next day. And so they've basically taken something that was a real specialty product available to people who can afford it and now brought that down to a much more commodity level. We're going to see more and more of that from 3D printing, which is reinventing business models in very different ways, in very meaningful ways, too.
Wow, that's really interesting. So over the past year, what do you think the coolest new technology that you've seen is?
So hard to say which one, because we're seeing some maturing of some things. What I love that's happening right now in some places is around IoT, because we've gone this massive explosion that's happened where previously IoT was a handful of things. Now we're seeing measurements occurring everywhere, whether it's on a band, a car, a razor blade. Everything is being instrumented. But I don't think that those are really the sort of really wonderful things. HoloLens is fascinating. And HoloLens as a technology that's introduced as commercially viable and available, that to me is sort of one of these discontinuities. So there's all of these interesting things that's happening, but HoloLens is the discontinuity that I think is going to change so many people with so many things that they do.
Yeah, you know what? I want to talk to you in depth about HoloLens because we've got companies out there that are supposed to be kind of state of the art, and they're having trouble with touch screens in some cases. And here we are doing these incredibly just brilliant holograms. So we have to dig into that. But before we do that, I want to talk to you about some of the stuff that we have coming out. We have Windows 10 on the horizon.
Yep. And
one of the big points that everybody makes about Windows 10 is that it runs across all platforms. Runs on phone, Xbox, PC, everything.
Yep.
And explain to us what the benefits are of having an OS that runs across all platforms.
So there's two ways of looking at that. You can either look at the bottoms up or from the top down. Let me take the top down view because that's the sort of user perspective on it. And I think that's a good place to start, which is the ubiquity and continuity of the experience that I have, which means if I actually interface with some piece of technology, the nature of that interaction moves with me. The device doesn't have to move with me because that's kind of the old mobile world is I had to pick it up and carry with me. It was a phablet. I had nowhere to put it, so I had to have a backpack to put my phablet in. But the subtle difference now is that the experience is mobile. The experience moves with you. And in order to do that, there's then a whole bunch of underlying plumbing. So if you make that, if that becomes the meta point, then I can come bottoms up from a technology perspective that says, now we actually can, across a multitude of devices with big screens, little screens, maybe even no screens, be able to actually interface into this compute capability. There's a really important part of it, which is the addressable market for an ISV, because previously the market was segmented into silos of small things, big things, portable things, non-portable things, and each one of them had their own sort of ecosystem. And to the developer, now you've got this sort of common platform. So you can write the application essentially once, and then it adapts itself to these various platforms, small screens, big screens, touch screens, no touch. And so it creates this new marketplace for ISVs to make money, which is really what drives the ecosystem of platforms, is the availability of sockets to plug in. And so now you're no longer constrained to only writing to a gaming platform or only writing to a phone. As the ISV, the breadth of the platform space that you've got is now huge. The installed base is huge. The future installed base is massive as the addressable market. But the essence for it is actually from the outside, which is that the user, I get this sort of familiar pattern of interaction no matter where I go, and the navigation scheme is constant. The place that manifests today, the things that we're showing today, is actually in the touch version of Office, which is you're starting to see that run on multiple devices, the sort of universal app as it's called, and it behaves the same in all cases. If you know how to use it on one, you know how to use it on the other, and you don't really have to say, well, what's the UI paradigm of this manufacturer or that manufacturer? It's a very natural way in the application of continuing how you do that. Adoption is easy, cultural change is easy, change management is easy. How you move people there is actually very easy because it's actually consistent across. So it's two ways. It's the platform side, the money for the developer, and then what the user gets, because you have to always remember about, so what's in it for me as the user.
Wow. The universal interface thing is really intriguing because we hear that all the time from our customers. Hey, I know how to use it on a PC, but it's kind of tough to use on my phone, or it's,
right.
You know what I mean? And so I think that's going to be huge. Also, the fact that developers can write for one platform and then that application is available everywhere is also huge, because that makes us a much more attractive platform to write for just because of the installed base out there.
Of course, the installed base and then the future growth as well. But if you go back and think about how you might have written code 10 years ago, let's say Windows 95 timeframe, you would have had, let's say in a web page, all this conditional code. If screen size equals X, then do that. And if buttons equals yes, then do this. There's all this conditional stuff in your code. And then you had to say, well, if browser equals IE, if browser equals Safari, if browser equals this, if browser equals that. And your code was actually this whole tree of stuff. What the universal platform does is actually gets rid of a lot of that, the conditional things where you actually, it's done at a meta level. And a lot of that stuff is taken care of by the platform in terms of screen resizing, touch, no touch. And so for the developer, it's actually not only better, but it's easier to write to run across multiple platforms.
Yeah. The other thing that I wanted to talk about a little bit was the new trend towards these really small stick PCs. I think Intel just announced one. Yeah. And the reason I wanted to bring that up is because I just think those things are cool. I mean, that's pretty intriguing.
Such a geek.
I am a geek. Absolutely. But think about it, right? I mean, we could make a PC now that's, 3 inches long and an inch wide that plugs into an HDMI port. All I need to work from home is that and my 42-inch, monitor and a Bluetooth keyboard and mouse, and I've got the world's smartest smart TV.
So actually, let's take that in. There's multiple time frames for that scenario. Let's look at where we are now, and let's look at where we might be in 5 or 10 years' time. Because where you are now says, I've got display capability. It could be small display. When you see some of these telephones that fit into a docking station that suddenly become a PC because they got a keyboard and a bigger screen, they have different connectivity, they have USB ports. You've got that, but you've also got the scenario you described, which is these teeny tiny little sticks, something like a Net Arduino board that actually costs $40 on Amazon that runs .NET, it communicates, you can put random I/O stuff on it, and you can put in your pocket. The reason that you want to do that is, A, portability. What it's doing, though, is opening up a massive space in the IoT side where suddenly the ability to do data acquisition everywhere, that bar of entry, what I'll call the last inch. We used to talk about the last mile. This is like the last inch of being able to connect. And these little computers are doing that. And so the sticks that you talk about is when I carry my PC with me. But in a period of time going forward, let's say in 10 years' time, imagine your television set 10 years ago. You had a 42-inch plasma panel, and you had to get a truck to bring it home. It was this thick, not worth that much today. It probably cost you 10 times what it would cost today, maybe even more.
Had to reinforce the wall.
Exactly. You had to brace the wall to mount it. That's all gone. And what's also happened with that is that the compute capability that's in your TV set is massive now. It's huge in terms of what's in there. Particularly when you think about the amount of computing in a 4K TV screen, how many pixels you're dealing with, the data rate. So regular HD data rate's about 17 megabits a second. So uncompressed 4K, you're running into 60 to 80 megabits a second just coming in of pure data, which means 100 meg Ethernet's not going to do it. You've got to go to at least 1 gig Ethernet just to communicate. to get that stuff. So there's this big computer sitting on a TV screen. So why can't that computer adapt to you? Why shouldn't you be able to come in and say, hi, my name's Bob, and I actually want to do these things. And then Cortana that's running in your TV says, oh, hi, Bob, I know you just flew on this plane, and we're staying in a Marriott hotel, and we're doing all this stuff. So there's a scenario which says that those sticks are short-lived in some of the models because you're carrying it now so you can add capability to a display somewhere else. But that display is a pretty smart display. Why do I have to add? It actually has memory, CPU, display, maybe even has a keyboard. Maybe it has touch. Maybe it doesn't need touch because you just wave your hands at it. And so I think that there are scenarios which are short-term things like some of the stick things you see today. The place that I see that getting more interesting is actually in the shrinking of the technology that's allowing us to get to this massive ubiquity. The cost of entry now is pennies as opposed to hundreds of dollars to actually instrument everything. And so I think the miniaturization is going to drive there. It leads to some wonderfully interesting problems, like we've run out of IPv4 addresses. And so we said, let's do IPv6. And it'll be infinite and it will never have a problem. And the question is, when are we going to hit that bar? Because we're going to hit it. When every pencil and every razor blade has an IP address, at some point we're going to have a conflict. And so I think the blossoming of that end of it is going to be massive.
Awesome. Can we talk a little bit about the Surface Hub?
Yep. Surface Hub, I think, is interesting from a couple of ways. And let's look at it from the people perspective. Even in setting up this call that we were setting up, but how much time is wasted setting up a meeting where you have people in a room or maybe even have people remotely? At least 5 minutes of every meeting is people futzing with cables and doing things and really wasting time and then not sharing output. And so Miracast is actually a big thing. A lot of our new conference rooms on the campus now are configured with Miracast. So I just walk in with my Surface, I connect to the Miracast, and suddenly I don't have to worry, is it HDMI, DMI, get a cable, do I have a right connect, do I have the little dongle thingy with me? All of that's gone. And so that's the first step. But the next step, I actually think, is when we put a persona into the meeting room, which is today, a meeting room can have a schedule. A meeting room's like a person. It has rights, it has identity, it has a place, it has time, it has assets. And so that meeting room has a schedule. It knows what meetings are going to be there. By the way, it happens to know who's in the meetings because it can read the schedule to see who is invited. It can also tell who's going to be local and who's going to be remote because it knows where you are because there's a little thingy that's sticking to you that tells me where you are. So it has all of this knowledge about the meeting and the participants. And so when I come into the meeting room, why doesn't the meeting room set up for me? How come my PowerPoint is not set up on the screen? All the remote people are connected. There's a SharePoint team site, so I've got that up on a whiteboard already. We have the meeting. Everybody comes in. You have the meeting. Somebody takes notes in OneNote. It gets automatically distributed to everybody. That scenario is very real, and the Surface Hub suddenly makes that very practical. So we could have custom built that. It would have been an interesting, project to do it. Now it's just a commercial thing that you would get, which is how that hub then participates and allows people in a room, or actually people in multiple rooms, some far away maybe, to actually participate in that conversation and be super productive really quickly. And so if you take every single meeting that occurs and the cost of 5 minutes for the 5 or 10 people in the meeting, it doesn't take very long to actually get the real benefit, the real business benefit of the hub in that sense. So I think that that's a ready-made market. The demand for that, I think, will be incredibly high and will lead to instrumented buildings. I think it's one of the things that will lead us down that path to actually have buildings that are better instrumented outside of the HVAC, to actually be instrumented around the people in the building and the work that goes on in the building at the same time.
That's awesome. Yeah, I saw the demo on stage.
Yeah.
It was actually very impressive. And if anybody's watching this, you can just go to Bing, type in Surface Hub, and there's plenty of material out there if you're not familiar with what a Surface Hub is.
Lots of videos.
Yeah, but now the coolest thing,
Yes.
and I am a geek. I told you that earlier.
When we started. Yep.
Yeah, when we started. But the coolest thing, I think, is HoloLens.
Yeah, it is.
And that's a real product, right?
It is very real. There are some really amazing things, which was that there were a whole bunch of people tied up in a building somewhere who couldn't talk about what they were doing for many, many, many years. And suddenly there was this explosion of stuff. And I mean, one of the reasons we talked about it then was because the APIs are in Windows 10. the SDK for HoloLens is Windows 10. And the API, if you go looking, you'll actually find them there. We'll talk more at Build about it and sort of how that works. But that was sort of the confluence of things which led to this amazing sort of declaration of here's some new stuff. And the interaction, the people's reactions were really interesting because there were some people who are inherently gamers who said, I can play Minecraft in 3D, or what would Halo be like if I did this? So gaming is a very natural one, but you would be amazed at how many commercial applications we're seeing where our commercial customers are just lining up thinking about what they could do with this device. The sort of industrial maintenance scenarios are, there's a whole series of those that jump. There's a really interesting odd scenario, which is we talk about multidimensional data and data cubes, but generally those data cubes are shown on a 2D screen. So let's say you've got 3D data, which is actually looking at HoloLens, and you walk around your data, and it's kind of like Jenga. You pull blocks out, and you have a look at them. What would that look like to somebody who's watching you? So there you are. You got this little helmet on, and you're in free space moving around and looking at things, and there's somebody just videotaping you, behaving like this crazy person because you're feeling in free space. But the commercial applications are amazing. Things like robots and how you might set up an industrial robot. How you might think about trading information and a trading desk and how that would look like. Augmented reality for construction. Augmented reality looking at vibration on a particular machine and matching that up, and machine learning sitting behind it. And so the scenarios that flow out of it, really, there are a lot of people coming to us and saying, I think I have a scenario. Would that make sense? And so the what's going to come out of this is actually, we've talked about next user interfaces, next-gen user interfaces. This is what a next-gen will look like, because we've kind of been in the current gen for a while. Touch was probably the most recent thing that we added in voice. But natural user interfaces, 3D changes that dramatically. But when you actually open up that HoloLens, that little helmety thing, and you think about what's inside there. So there's CPUs, GPUs, memory, Wi-Fi connection, battery. Think about all the noise that's going on in that device, these special little lenses. And I was reading a paper the other day about what it takes to produce, to rasterize the 3D images at that level of granularity so that in real time you can walk around it and see different angles, which is what holographs are about. And so I actually wrote down some of these numbers just because I was amazed. So this benchmark was done on what's called a cylindrical hologram, and on a 3.4 gig Xeon, which is a pretty big chip. It would take 4,406 hours to actually rasterize so that you actually could walk around it and actually get the view in real time. So they then looked at what happened if you put that on one of the NVIDIA GPUs and did a bit of parallel processing, and it went from like 4,400 hours to 110 hours to be able to do that. And so buried inside this HoloLens is this new holographic GPU that we've created as a custom chip that actually can do this in pseudo real time. And so one of the constraints to getting this done was the ability to produce that chip that actually could manifest the stuff in real time so that you can peek and poke and change and do the kinds of exercises you've seen in the videos. That's what makes HoloLens amazing. So it's the hardware. We had to do a lot of stuff on the hardware, and then this magical software that I think will change it. When you get to commercial availability, I'll bet there'll be a whole bunch of gamers lined up at midnight trying to buy one of those things, no matter what the price.
Oh, yeah. I mean, so the coolest thing from a gamer standpoint that I saw, and this is just, this is just tiny. It's the implications are massive. This is just one small piece of it. But, in the demo where they're walking around and they look down on the floor and you can see sheep walking around because they're playing Minecraft, or there's dynamite up against a wall and they click a button.
Explodes,
and it explodes, and then you can see into another Minecraft world.
Yeah.
I mean, just imagine how cool that'll be. I was joking with my wife. I said, there's going to be some no wearing HoloLenses while driving rules that come up. But then I thought about it, and driving while you're wearing a HoloLens might actually improve the experience, right?
It could.
It could become a GPS.
You could get very interesting sort of sensual behaviors of where things are around you.
Yeah.
We did a project very early on with the guide dogs in the UK that is very similar to HoloLens. What happens is that you wear a special headset that sort of sits on the bone, so you can actually feel that it's intended for people who are sight impaired, but not necessarily. And what it did is it created this 3D audioscape in your head. And so depending on where you are, when you walk past a park bench, you'd get this pinging saying there's a park bench to the left, there's a dog to the right in your head. And HoloLens is actually the same thing, because instead of being pinging in your head, this 3D space is actually both visual and audio, so that as you move your head, it moves with you. And if you just think of the computing that's going on as you sort of turn, and completely seamlessly the scenery moves with you, that's amazing. That's just amazing.
I'm excited. I can't wait to see one.
Yeah. No, they're great. I must be honest, at Tech Ready, I saw one. I kind of wanted to get hold of it. It was the only real working one, and it was on a sort of handcuff to somebody's hand so that nobody could take it.
Yeah, and Tech Ready was 4 months ago? 3 months ago?
Yeah. No, late January, so 2 months ago.
Late January, 2 months ago, yeah. So I'm planning on attending, I think July is the next one.
Yep.
And hopefully we'll be handing out free demos to everybody during the July Tech Ready.
Actually, you need to get a number. We're now serving number 3, and we're number 3,057 in the back.
That's right. Yeah, now serving number 1,268,000. Yeah.
Yep.
Yeah, I mean, but I have to admit, when I saw that for the first time during the webcast, I was just stunned. I was blown away. Yeah.
It was one of those, it's one of those sort of events in computing, but actually more technology, where you look at that and say, the world actually probably could be different as a consequence of this. More memory, faster CPUs, disk drives, that's all incremental stuff. Even as I said, touch was kind of incremental in that sense. But this was different. This actually said, wow, there's a whole bunch of things that open up as a consequence of this that are really going to change how people interact with machines, how they interact with their environment, how they interact with each other, how you can actually interact with people remotely as if they were local. What does a meeting look like if you're wearing a HoloLens? Today we actually got a flat video camera and we're sharing stuff. But if we both had, HoloLens, I would actually see this full body representation of you instead of just a flat picture of you with a flower in the back.
Yeah. The infamous taste of Premier Plant.
Exactly.
Yeah.
Is that plastic or is that real?
No, it's plastic. It's definitely plastic. Yeah. So I do these in Charlotte, and we have a floor that is not populated in the Charlotte building. Yeah. And so I've kind of commandeered a little corner and made it kind of my little taste of Premiere Studio. Yeah,
that works.
And normally I have all the blinds open, but it's horrible today. As a matter of fact, I went to lunch at about 11:30, and the thermometer in my car read 68 degrees.
Wow.
I was in there for maybe 30 minutes, maybe 45. I came out, and the temperature had already dropped to 48 degrees. So we had a 20-degree drop, and, the sky opened up and thunderstorms and everything else.
But that scenario that you talk about just there, which is the ability to measure temperature, and what you described was you were measuring temperature because you have a thermometer in your car that actually shows you those temperatures. But that's, I think, what one of the massive changes is going to be when we think about the sort of 5 and 10 year window ahead, is the measurements that are going to happen, whether they're measurements of natural phenomena, temperature, weather, wind, or personal phenomena being movement, location, those kinds of things, activity. The merge of those things together and the data that produces and what we can then do with that, that's actually going to be one of these massive changes. And the cost of data acquisition 10, 15 years ago, to actually have a thermostat that you could hook up to a network, that you could read remotely, that was expensive. And there was a whole bunch of proprietary stuff that was in there. And standardization, for one, has sort of shrunk that. Moore's Law has actually shrunk that to the degree that I think we've come over that cliff so that now everything is measurable. And now it's a matter of just saying, what do I need to know today? What do I need to know tomorrow? What are the decisions that I can make with this information? But the measurement of reference information is just blossoming. And what I think will come out of this is there's a very interesting scenario where data is now valuable. Data is a currency. Data is worth something. And a lot of people don't know what their data is worth. And so I think you're going to find people who are brokers of data, which says, why don't you give me your data and I'm going to aggregate that with somebody else's data and then we'll sell that to a third party. Kind of what a broker would do today, a shipping broker would do today when they aggregate things together. And so I think there'll be a redefinition of some marketplaces. There'll be a data marketplace where you can actually auction your data. You can sell your data. You can trade your data. I'll give you my data if you give me your data. And because of that really comes from the ability to measure, store, share, put security on top of it. From an application perspective, I think there's going to be a whole generation that's going to come out that's going to think about how we manipulate data and the value of data. Opens up a whole wonderful set of privacy issues about if I give you rights to use some data about me, you're not really allowed to give them to somebody else. And how do I know if you did? So there's IT work out there.
We can ACL the data and apply policies to it.
It would have to actually be a fairly scalable directory in order to do that. Yes.
Yeah, so it sounds like, I was going to ask you, my next question was going to be, how does the cloud enable some of this new technology that we're talking about? But you just answered it just then.
Well, let me just extend that in the broader context, which is you've got storage for one, which is the disk drive guys have to love what's going on because it's just storage is growing exponentially. But I think there's some really hard technical problems, which is around identity and security, which is if you think about you're sitting at a monitoring station and you get a message from a house that says there's a thermostat that's reading X or there's a water flow meter that says that the water's overflowing. So do you know that device? Do you know who that device is? Is that device allowed to do the things that it's doing? All this ACL stuff you talked about, where previously we only thought about that about people. Do I know who you are? Is there two-part authentication? Well, how does a thermostat give you two-part authentication? Does it actually type in a fingerprint or has a virtual smart card? How does that thermostat, how are you sure that it is who it is? And the sort of authentication of that and then the authorizations that come with that. And so that whole space, which you could call security, authentication, authorization, rights management, that's just going to blow because the scale of what has to be done is massive. Today, in many cases, that go back to the TV set we talked about, you're probably like me, so you do actually upgrade the firmware on your TV periodically. But we're in a small group. Actually, the people who are watching this video are probably in that same group.
I just upgraded the firmware in my headset.
Exactly. So you're in the category of 3 people who do that. There are a lot of people, my wife, for example, who would have no idea what firmware is, let alone that it needs to be upgraded. So there's a family of equipment that's out there today that's going to be very dated very quickly because it's going to be obsolete in its ability to actually be changed. On the other hand, if you look at some of what's going on in the cars, you've got the sort of classical car manufacturers where you produce the head end of the car and it lasts 15 years, and then it doesn't. Alternatively, you're getting some of these modern Tesla-like cars, which is just software, and so over the air, we download a new set of firmware, and you get some new features and functions in your car when you come in the morning. That rate of change, I think, will actually get amazing because if you can make the firmware upgrade seamless and transparent, safe, reliable, secure, and do the change management with you, which is when you come in the car this morning, you switch it on, it says, "Hi there, Bob. Nice to have you in the car again. By the way, we added the following features to your car. You can now stream this audio. We actually have anti-collision software that does this." I mean, your car could actually talk to you and have a conversation about the things that were added last night. That rate of change, I think, is going to happen quicker than most people think. And what's interesting is, who are the people who could absorb that? Who are the people who, what would most people do if they sat down in the car in the morning and the car started talking to them, a la Hal, "Hi, Bob. We updated your car last night." What would happen there? And so I think that the technology is going to go back into this really fast movement, and there'll be some people who are coming with it, and there's some people who are like, "I have no idea what this is about," who are actually going to stick to diesel engines with ignition keys. Remember ignition keys, the thing you used to put in a car and turn? Those things.
Yeah. You talked about the intelligent thermostat. All I want is a thermostat that sends me a text message when my kids touch it. That's it. That's all I want.
Actually, you don't want that. You want a hand that comes down and says, "Don't do that. Don't do that."
No, that asks me for permission. So if they turn it to 60, I want to be able to say no. Yeah. So Norm, where do you think we'll be in 5 years?
5 years is really hard. I was thinking back when we started the call, which was what we talked about a year ago.
Yeah.
We talked about 5 years, and that's all gone. That's all passé already. So predicting out 5 and 10 years is actually really hard. I do think that there are a couple of places I think we'll see changes. One of which is on the things that you carry with you. And we're starting to see an escalation of things because you carry a Surface tablet, you carry a phone, you've got a band, you're going to have something in your ears. We're starting to carry a lot of stuff. And so I think what's going to happen is that we'll maybe see less things and we'll see those things being tied together. So what the band will do is the band will actually have some transmitters in it of some kind that will aggregate into the rest of the system. So one of which is how many things are you carrying with you and how many things do you actually need, and will that change? I think that's one place we'll see some change. I think HoloLens will actually introduce not only sort of 3D, but I think we'll start to introduce people to having a much more natural interaction with systems rather than typing. But in Windows 10, one of the things you can do today is you can switch on the mic and you can go, hey, Cortana, and you can have a conversation. And that's the first step, I think, to people actually having a very natural conversation with the technology that it's around them. And so I think you'll see a change in the experiences that people have. That'll be sort of on the consumer side. I think you'll see home electronics, as much as we alluded to, that the half-life of a TV set when it was a big glass thing, was 20 years, and then plasma panels was 10 years, and LEDs were shrinking down. And I think that's going to move really, really, really quickly. And that there'll be a refresh of the thing that's in the home, primarily because of Internet of Things, where your dishwasher and your washing machine and your fridge now have ubiquitous communication. And so I think you'll see a refresh happening in the home, much as we saw a refresh happen in the technology. How that comes to us is, I think, is going to be really interesting. How do you actually acquire that technology? Because previously you would have walked into a big box store and do that, but I don't know how many big box stores they're going to be around for you to actually go and walk in. And so how people engage with technology, I think that will change as well. How you acquire technology, how you feel it, how you decide which one you like or not, that'll actually be a massive change. I think transportation will be another area where you see change. We're starting to see, we have GoGo on some of the planes where you're actually getting Wi-Fi coverage. I was on an international flight recently, and you can have GoGo the whole way from here to Europe. So you're starting to be much more ubiquitous. That's the first step. We're starting to see content delivery happening in transportation. I think you'll see more of that, whether that's in a plane, a train, or in a car, walking, or on a bicycle. How content gets distributed to people as they move, I think that will change as well, fairly dramatically. And then I think we're on the cusp of seeing base-level transportation like cars really changing a lot. I can tell from the relationships that we've got from the car manufacturers, each and every one of them is deeply engaged in reimagining what a car might look like in the near future. Not in 20 years' time, but in car cycles, which is 3 to 5 years' time. And so there's a cycle of transportation that will be highly tech. Not that it isn't today. A car is really like 20 or 30 computers with several high-speed networks all on wheels moving very quickly. That'll continue. I think cars will become much more sophisticated, and how you deal with transportation will change. And so content, transportation, devices, those are all things that I think are going to move super quickly. 5 years, absolutely. 10 years, definitely.
Yeah. So you mentioned something, actually two things that I wanted to ask you about. Number one, you talked about TV and resolution and how resolution goes up, devices go smaller, shelf life decreases immensely. I was at CES 2 years ago, actually, and they had 8K TVs, which I have yet to see kind of hit the market. At what point do you think we get, how long do you think it is before we get to the point where, they can't double the resolution because the human eye just can't make any, see any difference?
It depends. If you could have asked that same question. Remember we used to have this thing called standard definition in 4:3?
Oh, yeah. Yeah.
And then you got 720p. So, my God, this is amazing. How could I ever do anything better than that? And you'd go to somebody's house and they'd have a 10-foot screen and you'd watch football in almost life size. Well, that's just completely passé, and that was like only 10 years ago. Now you're starting to get 4K TVs available, 4K projectors, and people say, wow, that's amazing, 1020p. Oh, my gosh, that's just terrible, 4K. And so the ability, there's an amazing book that I read recently which talks about how the brain perceives color and position and how your eyes and your ears do that. And the question that's posed at the front of the book, I'll get you the link to the book, talks about when you reach your hand out to pick up a coffee cup on a table, how do you know to move your hand to reach the cup that's there? And it deals with this issue of psychoacoustics and psychovision. And it's very interesting about how your brain interprets sound and vision to be able to touch, do things, and move without bumping into stuff. You know, if you just think about how you walk down the room and you don't bump into things, and why? Because you know they're there. How does that all happen? And so the psychoacoustic, psychovision ability of the brain to synthesize all of this, I don't know whether 8K is a limit or not. There's a finite number of pixels that the eye can actually pick up. But it's more than just the pixels. The brain seems to be able to deal with the synthesis of these pictures and interpret flat things as being 3D just by mere shifts, minor shifts of some things that are happening. And so there's been some very interesting work that's done about psychoacoustics. If you go back, for example, and look at some of the 3D sound simulation stuff that was done, Ambionics is one of them, where you listen to how people interpret sound in their head, where you've only got 2 ears, but it sounds like you're in 3D. And you get 7-channel and now, Atmos, which is actually have sounds reflecting off the ceiling in the room. So I don't know if at what point we'll hit the natural limits of the brain to process. I think there's a big gap there to go. The question is, could I do something different with that bandwidth? That's what I actually think is more interesting, because in order to send, we talked about 4K being 60 or 80 megabits. When you get to 8K, you talk about 200 megabits a second. I think I could use that bandwidth to do more interesting things than just send you a higher resolution picture. What is the other information that I can send in that stream around what's going on in the picture? So I think there's better ways to use that bandwidth than just saying more and more and more of this, because that's valuable. That bandwidth is super valuable, and you should be able to send high-value data in there, not just the picture and the animation. Having said that, though, when you look at HoloLens and the ability to actually, how big are those images to actually give you that resolution? You need that kind of stuff to get there.
Awesome. Well, listen, I'd like to thank you so much for coming on the show. It's, as always, been awesome.
Cool. We have a date for next year, same time?
Absolutely, yeah,
We'll
absolutely. And I can't wait to see what's changed.
We'll do it. I bet you all of you said will be completely different, and we'll tell some more stuff about the future then.
Awesome. Well, I look forward to searching you out and finding you at Tech Ready.
I'll be there.
And without further ado, that's your taste of Premiere.